Welcome to your bearings assessment video. This is just to, we're looking at a few things on basic bearings to begin with, and just to use it to make your corrections. So, first question. I've got a map of an island, and a helicopter flies from Castletown to Foxville. What I've done here is I've drawn in the line between Castletown and Foxville. And how far does the helicopter fly? Well, what I need to do is I need to look at that distance, and I need to look at my scale. So 1 centimetre is 10 miles, so I'm making that distance 4.9. Now I will accept anything between 4.8 and 5.0. So when that's multiplied by 10, it gives me 49 miles. So I will accept anything between 48 and 50 miles. On what bearing does the helicopter fly? Okay, here's the thing now that we need to remember our key facts about bearings. The first is that north, so north is being indicated there, north is 0, 0, 0 degrees. So that's 0, 0, 0 degrees. The second bit is that bearings are always measured clockwise from north, so I need that angle. And the third bit is that I need to write it as a three-figure bearing. Okay, well, I think probably the easiest way to do an angle, to work out all of that angle, is to look at what this angle is and subtract it from 360 degrees, because I know the angle around a point would come to 360 degrees in total. So I'm going to look at what the obtuse angle there is. Line it up carefully, and I'm making it 140, somewhere between 148 and 149. So if I make that 148, now I'll accept anything between 147 and 150, because I thought it was about 148.5, so I accept between 147 and 150. What does that mean though? That's not the bearing the helicopter's got to fly. The bearing the helicopter's got to fly is 360, take away that 148, because it's clockwise, isn't it? It's clockwise there from north. So that gives me 212. The bearing there is 212 degrees. 212 degrees. Another helicopter flies from Bilton to Castletown. Okay, so it flies on this line from Bilton to Castletown. From Bilton, okay. So from Bilton, I need to look at my bearing at Bilton. So I'm going to draw my line due north. I'm going to measure from there. So what have I got? It's 62. Now I'll accept anything between 61 and, well, yeah, anything between 61 and 64. I'm making that about 62 or 63. So yeah, anything between 61 and 64. So I'll make it 62 degrees. And that isn't, though, the bearing. Remember, the three-figure bearing is 062 degrees. That's that question done. Okay. Next question. Shows the position. The diagram shows the position of two airplanes P and Q. The bearing of Q from P is 070. Calculate the bearing of P from Q. Right. So I know that this angle here, from alternate angles, I know that that's 70 degrees. And I also know that this here must be 110 degrees, because on a straight line that's got to add up to 180. Now I want the clockwise bearing from north, always the clockwise from north. So it's that 180 and it's 70 more. Okay, so that's 180 plus 70, which is 250 degrees. I'll have a look at the one underneath first, so that's this one here. Okay. Diagram shows the position of two people, A and B. I'm just going to sort out that. There. Who are on their Duke of Edinburgh expedition. Okay. The bearing of person C from person A is 062 degrees, and the bearing of person C from person B is 275 degrees. In the space below, mark the position of person C with a cross and label it C. Okay, Right, so from person A, 62 degrees. So let's find that bearing. From due north, I'm going round 62 degrees. There. And join that up. I'll write that in, 062 degrees. Just putting the 0 in to make sure that I'm not forgetting that at any point. 275 degrees. Okay, so I know that 270 degrees is due west. 270 degrees is 5 more than that. So it's 85 less than 360. So if I measure 85 from north, 80 and another 5, just got to make sure it's properly lined up. 85 there. It's nearly due west, but not quite. I'm going to join those up. So that bearing there has got to be 275 because I've measured that there to be 85 degrees, so that together would come to 360 degrees. So label the person C. Okay, the person must be there. C. That's your answer to that question. Right, let's have a look at this one more question here before we look at the trigonometry. Okay. Now, I made a mistake with this here, and I don't know why that's got a Z on it. Okay, Gregory is at O, and there are two roads. So he's here, and the two roads, one towards A and another due south to B is due south of O. Okay. Gregory walks towards A. Okay, that was the mistake I made. He's at O, he's going to walk towards A. On what bearing does he walk? Right. Okay. Well, all I need to do is use my finding angles knowledge. So angles on a straight line are 180 degrees. So that there, if I label that X, X equals 180. Take away the 115, which is 65 degrees. Careful, I've got to put it as a three-figure bearing, 065 degrees. Okay, Joshua's at A and walks towards Gregory. So walking this way. On what bearing does Joshua walk? Okay. Let's have a look at this. Let's imagine from A. So here's north A. And I could just imagine that carrying down south as well. And I'll show you why in a moment. Because I can use my facts here. I know that that's 65 degrees. So I know that this has got to be 65 degrees from alternate angles. So this whole bit measuring around clockwise from north is 180 plus 65 degrees, which equals 245 degrees. So that is the bearing which Joshua walks along. We'll zoom out a little bit. So Joshua must walk along 245 degrees, the bearing 245 degrees. That is the end of the bearings assessment, for the non-trigonometry. So that's what I would like you to mark, please, and make sure you're correcting. And do good quality corrections, please. Thank you. And have a look at the trigonometry, which I'm going to put together in a separate video.